Welcome back to the second part of our week one lecture for photo history, Photo 150. In the last video, we ended talking about in the 16th century when the camera obscura was kind of being formulated as not just a strange optical phenomena, but as a tool that people could use. We ended on this slide of this old illustration of how they work. Here is an actual, this is later than that, but this is a portable one that artists would use to make drawings in a location. So then maybe they're in, think of the places where perspective would be tricky. So maybe an architectural scene, like an interior with lots of pillars and things where you've got to have the perspective right or it doesn't feel right. Also landscapes. A lot of them were being used for landscapes. The idea was the image comes in here, light goes through the box. This one has a lens to actually help focus it and make it brighter. So this is kind of an advanced one compared to the earliest ones where it was just a little small pinhole aperture here. And then they had a mirror that would kind of reflect it up here onto this ground glass. Then you could put a piece of thin paper down and trace directly on top of it. So let's continue. I just wanted to be able to point that out to you. So by the 1600s, this is a real tool for working artists, not just an interesting phenomena. Like we said, continual improvements in lenses and optics. Think of at the same time, they're making advances in telescopes. At the same time, you have astronomers making these really important discoveries like Galileo and Copernicus. So things they're learning about telescope optics are being applied to lenses that are used in these camera obscuras. So it's making it much more portable, much more practical and usable. But it was still 200 years after this before the first real photograph as we would know it was made. Pardon my allergies. We've talked about there's advances in optics, but chemistry is the other part of the puzzle. So in 1725, Johann Heinrich Schulze stumbled upon the concept of silver nitrate being darkened by light. So he's doing some experiments and finds a strange phenomenon that it was light, not heat, that was causing this silver nitrate to darken. So this is a very important step, but still, in the 1700s, no one quite put all the pieces of this puzzle together yet. So you have lots of people making different discoveries in things that are important to photography, but no one can see the big picture, so to speak, and put it all together. So in 1802, Thomas Wedgwood tried to transfer images painted on glass to various light-sensitized substrates. So he's using, he worked in pottery and things like that, and he's applying different kinds of light-sensitive chemicals to these, trying to make images. And he was able to make some, but he couldn't stop them from darkening. So he also is using silver nitrate. He's figured out a way to make images on it, but he can't keep the images. So the light darkens it enough to make an image, but then it continues to darken. So eventually they darken so much that the image is gone. So kind of a big problem, but you can see they're getting closer. In 1816, a Frenchman named Joseph Nicephore Niepce and his brother Claude successfully made an image in a camera obscura. They used slightly different chemistry. They're using a silver chloride. They sensitized some paper with this silver chloride, and they made an image with it. But they had trouble with the stability of the chemistry, but they couldn't figure out how to make a positive image. What they got was a negative image. And when we get further down the line, you'll get to see this whole positive negative concept is very important in photography. So they got a negative and they couldn't figure out how to make it into a positive so that all the tones appear as we're used to seeing them with our eye. So he gave up on silver chloride and he started to work with something called bitumen, which is similar to asphalt that we use to pave roads with. In his process, the bitumen would harden in the light, and the softer areas that receive less light would wash away. So if you think about it, he's making an image that has kind of some relief to it, almost like a sculpture. So you would definitely, even with your eyes closed, be able to feel with your fingers the shape of this image made by the light-hardened bitumen. In 1827, he made the first photograph, an 8-hour exposure, if you can imagine it, of a bitumen-coated pewter plate. So he's not working with paper anymore. And here is that plate. It's hard to make out an image. This particular plate is stored right now at a museum in Texas. And as you can imagine, it doesn't come out of its storage very often because it's a very delicate, fragile thing, and they want to preserve it from any further fading or darkening. But this is what the plate looked like. The title of it is View from the Window at Le Gras, which is his estate. And this is kind of a slightly optimized view of it so you can make out what it is. So on the left you can see part of a window frame, and then there's a roof of another structure in the center. You can easily see the two kind of towers to the left and right, and there's some trees and a horizon in the background. But this is the first photograph. Here's another view, just to give you a sense of where he was doing this. The top left, that is the building still stands. So this is would be the view out the window. So this is, I believe, looking through one of these cameras. This is the actual window on the right. This is the window. And they set up a camera. I'm not sure if this is the exact one he used or if it's one similar that he built. But they positioned it where you could get an idea of how the photograph was made. And then the lower left, that is the camera that he used. So it looks very primitive. It definitely looks like they've removed the lens, but it was a box with another box inside that would slide in and out so you could focus it. Very primitive, but it worked. It still works to this day. You could make images with that. Here's another view of the window. Lower right, that's a picture of that same plate, but this is, you can see the image in it a little better from that angle that they're photographing it from. And then in the upper right, that is one of the rooms at his house where he would do some of his experiments with chemistry, and that was kind of his lab. So he attempted various ways. He experimented a lot with how to make his process more efficient with the light it would take to make an image, make it more light sensitive. Today we might say the term we would use would be faster. He's trying to make his materials faster so that they don't require as much light to make an image. You can imagine 8 hours is not very practical. You're not going to be able to make a portrait with an 8-hour exposure because no one could hold still that long unless, even if they were asleep, there would be some movement, and so that wasn't really an option at the time. In the process of this, he was connected to another man named Jacques-Louis Mandé Daguerre. Niepce died in 1833, so 6 years after making this photograph, and he still hadn't quite solved that puzzle yet. So Daguerre took over his experiments. He stopped using bitumen. He returned to other silver halides. The ironic thing is that originally Niepce was working with silver chloride, and today it's not nearly as common, but you can buy silver chloride darkroom papers, and people who use them swear by them for their tonal range and just their sharpness. But even the modern papers with silver chloride, they're not as fast, they're not as light sensitive as other kinds of paper that you can buy. But it's interesting that he was using that, and we still use it in a slightly different form today. But so Daguerre continued his experiments. He stopped using the bitumen. He went back to silver, light sensitive silver. Using the discovery of British scientist John Herschel, he was able to stop the action of light so that his images could be viewed in the light without darkening any further. It's a very important step. So a few people had figured out how to make an image, but they couldn't keep it. Herschel shared his discovery with him, and that was a really important part of this. It's being able to stop that action of light on the silver. And what was that discovery, you ask? There's a compound called sodium thiosulfite, or hyposulfite is how they used to refer to it. Even to this day, a lot of old school darkroom photographers will refer to it as hypo. The other common term that we use now is fix, and that's the third step in the development of a film negative or a print. You have your developer that brings the image out. You have some kind of a stop bath that halts that development, and then fix removes any of the silver that hasn't been exposed to light and that hasn't been developed. It removes that. So all you have is the developed silver. Anything that hasn't been exposed to light is removed, and the print is stable. Daguerre referred to his process as the daguerreotype, and rather than everybody who came up with their own process had various solutions to, should they patent it, should they not, should they license it. Daguerre sold his to the French government, and they kind of dealt with all the licensing and things like that to say who could use it. And the French government was very keen to associate itself with any kind of scientific and technological progress, because again, think of that Enlightenment mindset that reason and progress are the goals to strive for, and so it's kind of a prestige thing for your country to say, look, we've made this important discovery, no one else has done this before. The first mention of daguerreotypes was in 1835. So here's a quote from somebody talking about these. He hadn't released this to the public yet, but this is by someone who saw them. He said, "It is said that Daguerre has found the means to collect, on a plate prepared by him, the image produced by the camera obscura, in such a way that a portrait, a landscape, or any view projected upon this plate by the ordinary camera obscura leaves an imprint and light and shade there, and thus presents the most perfect of all drawings. A preparation put over this image preserves it for an indefinite time. The physical sciences have perhaps never presented a marvel comparable to this one." And here's the earliest surviving daguerreotype. This is from about 1835, so around the time that of the quote that we just pulled there. He had others. A lot of his work was destroyed in a fire at his house right before he announced this to the public, so they saved some, but this is the earliest that they can reliably date of all of his surviving work. But in 1839, Daguerre's photographic process, the daguerreotype, was announced publicly at the French Academy of Sciences and the Académie des Beaux-Arts, held at the Institut de France on Monday, 19 August 1839. So 5 years before that, he had it perfected enough that he could show it to someone, and he had all the pieces of the puzzle.